Hello students, welcome back to the maths class. In our last class, we have discussed some concepts about surface area and volume. We have gone through the concepts of cone and we have completed some of the questions of the exercise. In this class, we will solve some more questions about cone and we will move forward with some more concepts about surface area and volume. Okay. So, let us solve question number 7. It says, Shanti Sweets stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The bigger of dimensions 25 cm into 20 cm into 5 cm and the smaller of dimensions 15 cm into 12 cm into 5 cm. For all the overlaps, 5% of the total surface area is required extra. Okay. If the cost of the cardboard is rupees 4 for 1000 centimeter square, find the cost of cardboard required for supplying 250 boxes of each kind. Okay. So, this is the question. Let us now discuss the solution. Fine. Students, the dimension for the bigger box is given as length is equal to 25 centimeter, breadth is equal to 20 centimeter and height is equal to 5 centimeter. Okay. So, let us find out the total surface area of the bigger box. So, total surface area is equal to 2 into LB plus BH plus LH, that is 2 into 25 into 20 plus 20 into 5 plus 25 into 5, that is 2 into 500 plus 100 plus 125, that is 2 into 725 or it is 1450 centimeter square. Okay. So, the total surface area of the bigger box is 1450 centimeter square. Let us now find out the total surface area of the smaller box. Okay. Students, the dimensions of the smaller box is length is equal to 15 centimeter, breadth is equal to 12 centimeter and height is equal to 5 centimeter. Okay. So, total surface area is equal to 2 into LB plus BH plus LH, that is 2 into 15 into 12 plus 12 into 5 plus 15 into 5, that is 2 into 180 plus 60 plus 75, that is equal to 2 into 315 or that is 630 centimeter square. Okay. So, now we have found out the total surface area of the bigger box as well as smaller box. Okay. Now, total surface area for 250 boxes is to be found out. So, let us find it out. Okay. So, total surface area for 250 boxes of each type, that means 250 bigger boxes and 250 smaller boxes is equal to 250 into 1450 plus 250 into 630. Okay. So the total surface area for 250 boxes of each type is equal to 5,20,000 centimeter square. Okay. Now, as per the given question, extra area required by both type of overlapping is 5%. So let us find out what is the surface area of the overlapped area. Okay. So extra area required is equal to each box. Okay, this 5% is for each box. So that is 5% of 1450 plus 5% of 630. 104 centimeter square. Okay. So for 250 boxes, this is for one box. So for 250 boxes, what should be the area? It is 104. So for 250 boxes, it is 104 into 250. 26,000 centimeter square. Okay. So we have found out the total surface area of 250 boxes of each type and the surface area of extra overlapped area. So the total surface area of the cardboard sheet, okay, is the sum of both the areas. So what it should be? Let us find out. So is equal to 5,20,000 plus 26,000. So 5,46,000 centimeter square. Okay. So 5,46,000 centimeter square of cardboard is needed to construct the 250 boxes of each type. Fine. So what should be the cost? Cost of 1000 centimeter square cardboard sheet is rupees 4. So cost of 5,46,000 centimeter square sheet will be 546,000 divided by 1000 into 4. Rupees 2,184. So the cost of making 250 boxes of each type is 2,184 rupees. Okay. Hope you understand this. Students, let us now solve question number 8. It says, Parveen wanted to make a temporary shelter for her car by making a box-like structure with trampoline that covers all the four sides and the top of the car, with the front face as a flap which can be rolled up. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of height 2.5 meter with base dimensions 4 meter into 3 meter. Okay. Hope you understand the question. If you don't, then please read it out again. Okay. Now let us discuss the solution. Students, As per the given data, dimensions of the box-like car cover is length, that is 4 meter, breadth is 3 meter, and height is equal to 2.5 meter. Okay. So tarpaulin is required only for the 4 sides and top of the shelter. Hence, area of tarpaulin required is equal to, see, you just need to understand that the tarpaulin is required only for the 4 sides and top of the shelter. Fine. So 2 into L plus B. Okay. The formula should be 2 into L plus B into height, okay, plus length into breadth. This is for the base. We know the area of rectangle is length into breadth. Fine. So length into breadth, and 2L plus B into height is the lateral surface area. So the lateral surface area plus area of the rectangle, that is the top of the shelter, okay, which is a rectangular shape. So let us now substitute the values to find out the required area. So this is 2 into 4 plus 3 into 2.5 plus 4 into 3. So 2 into 7 into 2.5 plus 12. 35 plus 12, that is 47 centimeter square. Okay. So we need 47 meter square of tarpaulin for the desired work. Okay. Hope you understand the solution for this question. Students, let us now discuss about surface area of a right circular cylinder. Let us first discuss what is a right circular cylinder. Okay. You can see figure 13.6 that is given in your book. If we take a number of circular sheets of paper and stack them up, as we stacked up rectangular sheets earlier, what would we get? Here, if the stack is kept vertically up, we get what is called a right circular cylinder, since it has been kept at right angles to the base and the base is circular. Let us see what kind of cylinder is not a right circular cylinder. Students, observe figure 13.7a. You see a cylinder which is certainly circular because its base is circular, but it is not at right angles to the base. So we cannot say this a right circular cylinder. Of course, if we have a cylinder with a non-circular base, as you see in figure 13.7b, then we also cannot call it a right circular cylinder. So here we will be dealing with only right circular cylinders. So unless stated otherwise, the word cylinder would mean a right circular cylinder. That means a base that is circular and it is at a right angle to the base. So cylinder should be right angle to the base and the base is circular. Now if a cylinder is to be covered with colored paper, how will we do it with the minimum amount of paper? First, take a rectangular sheet of paper whose length is just enough to go round the cylinder and whose breadth is equal to the height of the cylinder, as it is shown in figure 13.8. Students, the area of the sheet gives us the curved surface area of the cylinder. Note that the length of the sheet is equal to the circumference of the circular base, which is equal to 2 pi r. See, just observe figure 13.8. So, there is a rectangle, and how this rectangle is being made, let us observe. So, this is a cylinder, and if I cut it from here and open it, so it will be opened up to give a So students, if I cut the cylinder from one side and if I open it, then we will get a rectangle. Now just think, the cylinder is being cut from here. So when I open up, this part goes like this and straightens up. This part goes like this and it straightens up. Okay, so now this part, suppose now they are in a straight line. If we open it, it is a straight line, just like this. This is just an example. This is not the exact dimension of the cylinder and the rectangle, but this is an example how it will look. So think, this part, the circumference of the circle after opening up becomes the length of the rectangle. And what is it? It is the height. That means the breadth is nothing but the height of the cylinder. Okay, so the circumference is the length of the rectangle and height of cylinder is the breadth of the rectangle. So curved surface area of the cylinder. Now just imagine the curved surface area, because the curved surface area is opened up to form a rectangle. So the curved surface area of the cylinder, what it should be? It should be the length into breadth of the rectangle. Length into breadth, it is the area of the rectangle. So what is the length? Length is the circumference of the circle, which is denoted by 2 pi r. Okay, and what is the breadth? This is the height of the cylinder. So the circumference of the base of the cylinder, which is represented by 2 pi r, it is multiplied with the height of the cylinder denoted by h to give us the curved surface area of the cylinder. So that means curved surface area of a cylinder is equal to 2 pi r into h, or we can write 2 pi r h. Okay, students, so we have found out the formula for the curved surface area of the cylinder, that is 2 pi r h. What is r? It is the radius of the base, because base is circular, and h is the height of the cylinder. Okay. In the case of a cylinder, unless stated otherwise, radius of a cylinder shall mean base radius of the cylinder. If the top and the bottom of the cylinder are also to be covered. Previously, it was a case of open cylinder. If top and bottom are to be covered. So what it should be? See, top of a cylinder is also circular and bottom of the cylinder is also circular. That means if they are also to be covered, they will give us their area. So area of the circle is pi r square and bottom is also pi r square, because we know area of circle is pi r square. If we sum up, it gives us 2 pi r square. So if the top and the bottom are to be covered, they will acquire an area of 2 pi r square h. That means the total surface area of a cylinder is equal to curved surface area plus surface areas of top and bottom, that is 2 pi r square. So 2 pi r h plus 2 pi r square. When we take 2 pi r as common, so we get 2 pi r h plus r. So therefore total surface area of a cylinder is 2 pi r h plus r, where h is the height of the cylinder and r is the radius. Okay, hope you understand this. Students, in both cases, that means for curved surface area and total surface area, we are using the value pi, which is equal to 22 by 7 or 3.14. Okay, for calculation purpose, we usually take its value as approximately 22 by 7 or 3.14. Okay. So students, let us now discuss example 3. Okay. It says, Savitri had to make a model of a cylindrical kaleidoscope for her science project. She wanted to use chart paper to make the curved surface of the kaleidoscope. What would be the area of the chart paper required by her if she wanted to make a kaleidoscope of length 25 centimeter with a 3.5 centimeter radius? You may take pi as 22 by 7. So students, just concentrate on figure 13.10. Okay. So radius of the base of the cylindrical kaleidoscope, that is given as r is equal to 3.5 centimeter, and height, okay, height or your length of kaleidoscope is h is equal to 25 centimeter. See, you might have a question for this purpose. What? You might think, in the question length is given, so why we are taking height? So just concentrate. See, this is a cylinder, okay, of certain height. If I make it to lie down, it will appear like this, isn't it? That means which was previously the height now becomes the length. So as length is given, we can take it as the height of the cylinder. Okay. So now question demands for the requirement of chart paper. Okay. So chart paper is rolled down to make the cylindrical shape. Hence, we need to find out the curved surface area of the kaleidoscope. Okay. So curved surface area is equal to 2 pi r h, that is 2 into 22 by 7 into 3.5 into 25. Okay. So this becomes 2 into 22 by 7 into 35 by 10 into 25. So 22 into 5 into 5. 550 centimeter square. So this much of chart paper is required to make this kaleidoscope. Okay. Students, let us now discuss exercise 13.2. For this exercise, we need to assume pi as 22/7 unless stated otherwise. That means if the value of pi is given as 3.14 in some cases, so we need to take the value of pi as 3.14, otherwise value of pi is to be taken as 22/7. Okay. Students, let us now solve question number 1. It says the curved surface area of a right circular cylinder of height 14 centimeter is 88 centimeter square. Find the diameter of the base of the cylinder. Let us now solve this. Okay. So students, let us now discuss the solution. Okay. So it is given that height of the cylinder is equal to 14 centimeter. So h is equal to 14 centimeter. And curved surface area of cylinder is 88 centimeter square. So 2 pi r h is equal to 88 centimeter square. So to find out the diameter, we need to find out the radius first. So, or from here we can do one thing. We know d is equal to 2r, isn't it? So we can substitute 2r by d and write down the formula as d pi h, because t is equal to 2r. Fine. That implies d pi h is equal to 88 centimeter square. D is into 22/7 into 14 is equal to 88 centimeter square. It implies d is equal to 88 into 7 divided by 22 into 14. Okay. 22 4 jar, 7 2 jar, 2 2 jar 4. So 2 centimeter. Okay. So diameter of the base of the cylinder is 2 centimeter. Hope you understand the solution. Students, with this we have come to the closure of this class. In this class, we have discussed some concepts about surface areas and volumes. We have discussed the examples given in your book and we have solved some questions, those are given in your book. Hope you have understood all the concepts and the solution for the questions clearly. You need to practice them by yourself. Okay? Keep practicing and keep smiling. Thank you.